Hello, you're welcome to the class today. We want to look at equations under capacitance in AC, the instantaneous current and instantaneous voltage equations, how they were obtained. We know from the previous class that we said that when a capacitor is in AC, the current leads while the voltage lags by 90 degrees. Now, how were we able to observe that? We are going to show how that is so. The equation that we are going to be deriving will be those equations that we have used before, but we didn't know where they were obtained from. The class today will show us how we obtain the result. Don't forget, this is Alfred Explains Physics. Here we simplify complex concepts in physics for students to understand. You're welcome once again. Do us well to click on the subscribe button and join us whenever we have class like this. So let's proceed. Now, we said that the instantaneous current when a capacitance is in AC is given by I naught sine WT. We also said that instantaneous voltage is given by V naught sine WT. These equations were obtained from the nomenclature of AC. These equations have been so. But we realized that these equations changed when we were discussing the capacitance in AC. So what has brought the change? How were they obtained? Let us look at them. Okay. When you are charging a capacitor, when a capacitor is being charged, the equation of current, the equation of the capacitor, of the current that is stored in the capacitor is given by this. Let's say this is equation 1. Here we can see that while the current goes through the capacitor to charge and store voltage on the plates of the capacitor, to charge and store charges on the plate of the capacitor, the voltage is being delayed over time. The voltage has to build up over time. Building up the voltage over time affects the voltage and delays that voltage. While current would have proceeded, voltage is being delayed before voltage tries to catch up with current. So if this is the equation, now this means we should differentiate. We should differentiate on the instantaneous voltage equation and substitute it back here. If we should do so, we should have therefore that dV over dt is equal to d over dt of V naught sine WT. If you differentiate this, it should give you dV over dt equals, this gives us, when you differentiate sine, it gives you cos. And then we are differentiating with respect to t, so this comes behind. We have V naught cos WT. So this is what we have. Now bring back this equation. Let's call this equation 2. Substitute equation 2 back into equation 1. We should have I is equal to C, or we say WC, which is from here. This W comes with the C. Then V naught, since this has become this, would I V naught cos WT. This is what we have after substituting. But remember, from the foundational class in trigonometric ratio says that cos theta is equal to sine theta plus 90. Remember this from the beginning, the introductory class in trigonometric ratios. So substituting this for this, it means that theta is the same thing as WT. Theta is WT. So we have I is equal to WC V naught cos theta cos WT substituted for this now. So we have sine open bracket WT plus 90 degrees. Plus 90 degrees. Okay, but I naught is the same thing as WC V naught. That means we can therefore have I is equal to I naught sine open bracket WT plus 90 degrees. This equation 3 is our equation for the instantaneous current when a capacitance is in AC. So this equation shows us that current from the nomenclature where the instantaneous current is this, it means when a capacitance is in AC from this equation, the current, instantaneous current, had gained 90 degrees. 90 degrees. So, therefore, the voltage remains what it is. Where is the voltage? We said instantaneous voltage is still V is equal to V naught sine WT. Call this equation 4. So instantaneous voltage remains what it is. This actually explains that the current leads by 90 degrees, as we all know, as we have explained in the previous class. Moving further and writing other equations under capacitance in AC, looking at this equation here, we said that I naught equals WC V naught. Suppose we should divide both sides by WC. It means that we have I naught over WC is equals to V naught. If we should divide or cross multiply here, we should have 1 over WC is equal to V naught over I naught. Remember in the previous class that we said 1 over WC stands for 1 over 2 pi FC, which is the same thing as capacitive reactance. Hence, we can therefore substitute capacitive reactance here in this equation, which means therefore that capacitive reactance is the same thing as V naught over I naught. Consider this as equation 5. So we can write capacitive reactance as this. Also, we can write the equation for the current as I naught equals V naught over XC. This equation also can be written as IC is equal to V RMS over I RMS. We can also write the equation for total voltage, when a capacitance is in AC. Total voltage will become V square equals VR square plus VC square. Taking square root through, we have this and this. This goes with this. We have V is equal to square root of VR square plus VC square.